Hello there, my name is Michael J.C. Jugar.
And I am Christine S. Guerra.
My name is Joshua Lloren.
I am Rachel Yos.
And I'm Lawrence J.C. De La Fuente.
We're here to talk about the limit of a function.
Our objective is to evaluate the limits using table of values.
So what is calculus? Calculus is a branch of mathematics focused on limits, functions, derivatives, integrals, and infinite series. This subject constitutes a major part of modern mathematics education. Calculus, originally called infinitesimal calculus or the calculus of infinitesimals, is the mathematical study of continuous change in the same way that geometry is the study of shape and algebra is the study of generalizations of arithmetic operations.
Calculus started around 17th century. The key idea of calculus is mathematics of change, the mathematical study of continuous change.
Calculus exists because of two people, and these are Isaac Newton and Gottfried Leibniz.
Isaac Newton. He viewed calculus as the scientific description of the generation of motion and magnitudes. Gottfried Leibniz. He was primarily focused on bringing calculus into one system and inventing notation that would unambiguously define calculus.
It has two major branches, the differential calculus and the integral calculus. Differential calculus concerns instantaneous rates of change in the slope of curves, while integral calculus concerns accumulation of quantities and areas under or between the curves. These two branches are related to each other by the fundamental theorem of calculus, and they make use of the fundamental notions of convergence of infinite sequences and infinite series to a well-defined limit.
Trivia. Calculus is a Latin word that means small stones used for counting, or pebbles.
How do we evaluate limits using tables of values? Same for example, let's say the function is f(x) equals x square root of 2 plus 1. As x gets closer and closer to 3, so what will be the limit? Based on the problem, it is closer to 10. Why? Why 10? Let's see in this table. So we have a table here. What is the approach of the function? We're approaching to 3. We're approaching to that value. What will happen to the function? What is the limit of it when we are approaching to 3? So what we are going to do is we will compress 3 and we will substitute values that are less than 3 or greater than 3. First, you will make a table. So the first table is less than 3 and it is near to 3. It says earlier it is closer and closer. It should be very close to 3. So that's why you have 2 and 2.5 and 2.9, 2 and 2.99 and 2.999. If you have assigned the x value, you can substitute now to our function the x value. If 2 raised to 2 is 4, then 4 plus 1 is equal to 5. Substitute again, we have 7.25. Substitute again, we have 9.41 and so on. Now look our answers in y. Where are we approaching? We are getting closer to 10. That's the limit of that side for less than 3. Now, if greater than 3, here in the right side, so greater than 3, you will substitute again to our function. As you substitute, we have 17 and 13.25 and 10.61 and so on and so forth. If you notice, where are we going? It is going to 10. Both of them are 10, getting closer and closer to 10. Therefore, we can say that the limit of the function f(x) as x approaches 3 is 10. How can you write the final answer? So like this. That's how you write the answer. You can read this one as the limit for the shortcut limit of x squared plus 1 as x approaches to 3 is 10. Again, the limit of x squared plus 1 as x approaches to 3 is 10 or is equal to 10. You can write also like this. And that's how you write your final answer. Both of them gets closer to 10, so therefore the limit is 10.
Let's go to our notation. Our notation is the approach value is what we call c. This is your function fx, and the 10 earlier is what we call the limit. That's how you arrange the notation for the limits. So this is read as the limit of fx as x approaches to c is L. Let's proceed to our next example. So here, let's say the limit of the absolute value of x as x approaches to 0, the function is absolute value of mod x as it approaches to 0. This is your C0. We are approaching to 0, so we will make a table of values less than 0 and greater than 0. Here, I will give already the x value which is less than 0. They are negative, but look, we are approaching the 0. And here, greater than 0, now if this is your x value, if you are going to substitute it to our function, what do you think will happen to y values? It will become positive because that is absolute value. So you will have 0.3, so the positive of it. How about to greater than 0? What do you think if we will substitute it to the value of x? So it is the same. Now look at the y value. As we are approaching to 0, both sides, where are we going to the limit? So 0, same answer, and greater than 0, the notation is the limit of the absolute value of x as x approaches to 0 is 0. So this is how you will write your answer.
Let's go with another example. If f(x) equals square root of 2 negative 6x plus 14 and it approaches to 4, determine the limit of this function. So where are we approaching? We are approaching to 4, that is our c. So make a table of values that is less than 4 and greater than 4. As you can see, we put here x values that is less than 4 and then we are going to substitute it to our function one by one. So as you can see, the y values here is approaching to what number? So we are getting closer to 6, and in the greater than 4 we have 4.001 and 4.01 and 4.015 and 4.02, and as you can see, it is also approaching to 6. So what is our notation here? The limit of x squared the limit of x square root of 2, negative 6x plus 14, as x approaches to 4 is equal to 6. This is how you will write the notion